Michelle, enlighten us.
I'm just guessing. Anything with an exponent less than 1.
Anything with an exponent less than, what do you mean anything?
I mean, like I don't know. All right. Okay.
Well, she's kind of sort of right. An exponent less than 1, but what's the anything part? A real number? Tyler? Okay.
Irrational number.
Is 3/4 a radical? No. And then, Michelle, you said something, anything to a something?
Yeah.
Anything, can I use X?
Yeah.
Can I use P?
No.
Can I use 16?
Maybe.
Yes or no? Okay, so anything. Let's just go with X.
X to the power of B.
X to the power of Y? Wow, that's pretty intense. Is that a radical?
No, it depends.
Y is less than 1.
Does Y have to be less than 1?
Yes.
What if it's 3/2?
Oh wait, that's what.
Is 3/2 less
Y
than
is
1?
a fraction.
3/2 is a fraction.
Yeah.
But it's both. It's not it is a fraction, but it's not less than 1. Wow, you guys are making this like 1,000 times more complex than it needs to be. Yes, Kabir. It's a root. It's a root.
Isn't that
The cube root of this. You didn't write it as a root. That's not a root. That's a root. That's fractional form. Yes. But did I write it the right way? No. Is it a
that
radical?
equals that? So
That equals that.
Correct.
Wow. You know what? Your mathematical language today is just like, whew. It's a root. It's a root. The x root, no, not x. I mean, x is okay, but I want to be consistent with what we've done in the past.
It's the
How about go for it, Brian.
nth root of x to the n.
Nth root of x to the n. Perhaps you've seen this from logs.
oh yeah.
Yeah, logs, and we did fractional equations, and you were solving for, I can't think of something off the top of my head, but 8 to the 2/3. Hi, what's 8 to the 2/3?
Cube root.
Have we forgotten
Yeah,
everything?
4.
4? Is this 4?
Yeah.
Okay, 2 ways you can do it. There's 2 ways you can do it. You can say that, well, actually, there's 3 or 4 ways you can do it. You can say this is the cube root of 8 squared. Cube root of 64 is 4. You could say it's the cube root of 8 squared. Yes? Those both give you 4. Okay? Or you could say, rewrite 8 as 2 cubed to the 2/3. Rewrite 8 as 2 cubed. Yes? This is how we pretty much did it with logs. Boom, boom, and then what happens with the 3 times 2/3?
They reduce.
They reduce and you get 2 squared. All of these are 4. Which way should you do it? Which way is best?
Whichever one.
Whichever one. Well, they all
Find the
work.
answer.
They're all giving you the correct answer.
Well, then
You
all
should
of them
use-
work.
Right, but which one should you use? The one that you like the best. You should use the one that you like the best. Okay, so great. Those are radicals. Let's do some solving. Well, let's go back. Square root of x equals, how about 3? There's an equal sign. That's an equation we're solving. There's an equal sign, which means it's an equation, which means we're solving. How do you solve that?
Square both sides.
Square both sides. What happens when you square both sides? What are you changing in the problem?
Getting rid of.
You're getting rid of the root, but somebody else said, what are you changing? The degree. You have to be careful. When you square both sides, You are altering the degree, which means you are potentially altering what? Excellent, the number of solutions. What's x?
X.
What's root x squared? X. Yeah, root x squared is x. And 3 squared? 9. Check. Don't just circle your answer. Check. Is the square root of 9 3? Great, move on. It is. What about the square root of 2x minus 5 equals 10? Square both sides. Square both sides. Figure it out, check your work. Figure it out, check your work, check with your neighbors, see if you guys get the same thing.
That's 2x minus 5 or 2x?
2x, it's the square root of 2x minus 5.
Would you prefer decimal or?
No decimals, no. No, decimals, get over it.
So
Yeah.
it's proper fraction?
Correct, no, 5/4. 1 point, no, whatever it is, I don't know what the answer is, but like 7/3, done, move on. Not 2 1/3.
No, I mean improper fraction.
Improper, you said
I said improper.
mixed number,
No, I said improper.
whatever. What's the answer?
105 over 2.
105 over 2? And is that what I'm getting?
Yes.
Yes? Okay, what happens when you square root 2x minus 5?
2x minus 5.
2x minus 5 equals 100. I'm going to skip steps. 105 over 2. Okay, square root is a radical, but not all radicals are square roots. Sometimes the radicals are, as we saw earlier, cube roots or fifth roots or whatever. So what if I give you the fifth root of x to the 6th equals
0.
64? No. 625. It might be nasty, I don't know. I have no idea. It might be nasty. You can't square both sides. Well, I mean, you could, but it won't get you anywhere. Squaring both sides will not get you anywhere. You have several options, like we did here. You have several options. Maybe you want to rewrite this as x to the, what would the exponent be? X to the 6/5. I had it right the first time. What number was it, 64? Wait, hold on, give me a second. I had it right the first time, 64, go back. It's much nicer, trust me. I think it is, you know what, I wouldn't trust me, I've already changed it twice. I believe that's gonna be nicer. Anyway, you could, option 1 is rewrite it as x to the 6/5. You okay with that? This is one of several options. Okay. Nate? Okay, change 64 to 2 to the power of 6, sure. Do you want me to leave the 6/5 alone, x to the 6/5?
Yeah.
Okay. Still doesn't tell me what x is, you have a big step to go. No? Okay, let's go back. Let's go back here.
When you multiply 6/5 by like 5/6 by the reciprocal,
Yes, why are you raising it to the reciprocal?
because because you want to make the degree of x 1.
You want to make the degree of x 1. So you raise
Yeah.
to the reciprocal power. Now you understand why I use 64. You want to raise to the reciprocal power because power property, you multiply exponents. So that's 30 over 30, which is 1. Or you can cross reduce and say 6 over 6, 1. 5 over 5, 1. So on the left, you get x. On the left, you get x. What do you get on the right?
25, I mean 32.
The 6's reduce. This is the same thing as 6 over 1. 6 is reduced. You're left with 2 to the 5th. 32.
2.
Nope. I circled it. What did I not do?
Check.
Check. Don't be lazy. Do the check.
Well, looking at the wrong
64 minus 5 is 50.
No, I plugged it into the equation. 32.
Does it work?
Yeah.
Okay, let's do some harder ones. Let's do some significantly harder ones. Root x plus 5. The 1 is not under the radical. The 1 is not underneath the radical. Square both sides? Alright, guess we're gonna get rid of the radical?
Yeah.
Let's try. Let's try. Oh my goodness, these numbers. Sometimes they're good. When you square both sides, do I get x plus 5 plus 1?
No.
Why not? I squared.
X plus 5 minus
Because you
1.
have to FOIL it out.
Yeah, I FOIL it out. So here's the question. X plus 6 quantity squared does not equal x squared plus 36. There's a whole middle term, yes? So if you just tell me that you squared the x plus 5, the root x plus 5, and then you squared negative. So we can square both sides. Is that what you want to do?
Nope.
Mateo, you say no? You have a better option? Sure you do. Go for it, Mateo. You know. If I'm not going to square both sides, I got to do some kind of altering.
Move 1 to the.
Yeah. Let's add 1 to the other side. Let's add 1 to the other side. Really? Yeah, watch. Be careful that plus 1 is on the, not underneath the radical. It doesn't matter where you start, you have to square both sides. It doesn't matter where you start, you have to square both sides. This is a problem that's going to involve double squaring. Root x plus 5 quantity squared. X plus 5, fantastic. This is not x plus 1. If it helps you, write it out and do the FOIL thing. If it helps you, write it out. If you can do it in your head, fantastic. I get
X plus 2.
there you go, x plus 2 root x plus 1. Distribute root x times root x. X plus root x plus root x is 2 root x. 1. Now what?
combine.
Subtract, yeah. You need to isolate the root. You need to isolate the root. But I'll tell you what, this is nice because when you subtract x from both sides, what happens? Yeah, it's gone. So I'm going to subtract 1, which is 4. That equals 2 root x. Yeah? What's x?
4.
4. So that was pretty nice. The x is reduced out or subtracted out. Did you check? Divide both sides by 2, you get 2. Square both sides, you get 4.
Oh, yes.
Does 4 work? 9, 3, yeah. Okay, so lucky for you, they're not all so nice. Let's do one that's really hard.
How does that work?
Pardon me?
How does that
I'm
work?
being sarcastic. Like, lucky for you, they get much harder. They get much more complex. Let's do some math. Oh, let's do. No.
Root 1.
Root 3x plus 10 minus 4 equals x. And we'll do that one. That one's good. That one. That's a good one too. Amit, what did you do first?
I added 4.
There you go. Add 4. You want to isolate the radical as much as possible. Continue, Amit.
And then you square both sides.
All right. So the left, you get 3x plus 10. Square is square root. It's gone. So what's x plus 4 quantity squared?
Say x plus 6.
Now what?
Combine like terms.
Okay. How do you want to do that, Kabine?
Well, I just subtracted 3x and subtracted 10.
Why did you subtract 3x and subtract 10? Why didn't
You
you?
want to get it equal to 0.
You want to get it equal to 0. It's a quadratic. You want it equal to 0. It's quadratic. Factor it, or quadratic formula. Hopefully we can factor it. So there's a reason why we did all that factoring last chapter. X plus 3x plus 2.
Yes.
And what's x equal?
Negative 3.
Both work, are you sure?
Yeah.
I don't think both work. Negative 3 is square root of 1 plus 3. This is square root of 1 plus 3, 2. No, I don't think negative 3 works.
It does. 3 times negative 3 is negative 9. Plus 10 is 1. 1 minus 4 is negative 3.
Thank you. Yes, it works. Negative 2, negative 6 plus 10 is, I suppose that is 4. Square root of 4 is 2.
Minus
Yeah, we're good. Yes, they both work. All right, 2 more. 2, and then I'm going to torture you with word problems. I know, it is my absolute, it is like the most funnest thing to do ever. You don't want to correct my incorrect problem? There's a word problem called.
No, word problem, so
There are lots of word problems.
Phobia.
BB phobia, I like that. PP, BB phobia. That's a good one. All right. There's a lot of 4s in this problem, which I don't particularly like, but root x plus 4 plus root x minus 4 equals 4. What's going on? Two binomial radicals. What am I going to do?
subtract one from the other side.
What's that, Nate?
Subtract one from the other side.
Subtract 1 from the other side. What do you guys think? Should I subtract one of the radicals from the other side? Well, I hear no response. So if you don't want to subtract one of the radicals from the other side, what do you want to do instead? You want to just square it flat out? You want to just square it flat out?
No.
You're either going to square it flat out or you're going to move one of them to the other side. Which one do you want to do? Say that again. What do you want to do, Amelia? Or Tyler? They're both going to be ugly. I highly recommend that you move one of them to the right side because then you're going to get 2 root blah, blah, blah. Should we do it the uglier way so you can see why it's uglier?
No.
No, we're not doing
Here's what I mean.
We're not going down Brian's path again.
Yeah, we're not going down. Oh, that's right, Brian's back. Let me just give you a side note. So you have a plus b. I'm just going to use a plus b instead of root. And we're going to square that, which is a squared plus 2ab plus b squared. Follow? Okay, well, my a is root x plus 4. Cool. Square it. We're good. My b is root x minus 4. Square it. We're good. What about the middle? You're going to have 2 of this root, that root. I don't think that's a good root. Oh, I get it.
Uh-huh.
That one just came naturally. I should get some credit. Which one do you want to move? I don't care. Pick.
Someone just
Go with the negative? Okay. I'm disappointed. That was seriously.
Your best one.
That was not my best.
wait, what's extraneous?
Extraneous. Extra. Right, that happened yesterday. Extraneous solutions. Solutions that happen when you alter the degree. So you got to check. That's why I'm like, did you check? Did you check? Did you check? Well, you still should just watch out. But the most important time is yes, when the degree changes.
Wait, no, mine worked.
I'm going to square both sides. Woo! And you know what? The left. I like the left. What's root x plus 4 squared? Fantastic.
No.
You added wrong.
Guys, there's nothing wrong with making a mistake. You don't need to announce to the whole class that we made a mistake. You're still going to have a root. This is one of those where we're going to have to square both sides twice. You want me to write it out, or can I skip a step?
Skip step.
Okay. 4 squared is 16. Okay. Minus 4, root x minus 4. Minus 4, root x minus 4 is minus 8. Root x minus 4. Watch out for the subtraction sign. Watch out for the subtraction sign. This becomes minus the quantity x minus 4. Okay, something wrong there?
Wait, not plus.
Yeah, it becomes plus. What I just get done telling you, watch out. And I made the mistake. See, I made the mistake. I'm not going to laugh and run out of the classroom.
You didn't run it.
You need to isolate the radical. Oh, check it out. What happens when you subtract x from both sides?
They subtract out.
They subtract out. I'm gonna add, ready? The x's subtract out. I really shouldn't do that. Add 4, you get 8. There's,
Subtract.
yeah, I'm gonna do that in a second. I don't know why. This way. 1. Square root of x minus 4 equals 1. Subtract 16, get negative 8. Divide by negative 8, get 1. So you get square root of x minus 4. Oh, that is so nice. And when you square 1, you get 1. Not so bad. I thought it was going to be horrible. You guys got lucky. 5?
Yes.
Check.
I did.
It works.
I didn't.
I don't know if I believe in me. 5, 3 plus 1 is 4. Yes, it works. Okay, one more. I said it was going to be 2. That was 1. One more.
That was one.
What about the trust level?
Trust level.
Oh, you think I'm okay? Is that what you're saying?
No, you're like, I don't trust them.
Oh, you're right. All right, last one before we do word problems. Because if you have a Phoebe phobia, which I think Phoebe is going to come up again.
Is she flying to another planet?
I don't know where she's flying this time.
Crashing back.
I think she has time traveled, hasn't she?
You
I
know
don't
what?
think we've done that one.
She
I
just died in
just
the
added that stuff.
And then she got,
I think we've
She
only
doesn't
done,
get eaten.
but then she flies out
Have you
again.
done it for
You know, she's Phoebe.
Well, exactly, she's Phoebe. She's not going to not get eaten.
Revive.
Revival.
Say that again.
Is there like an image of Phoebe? She's like on Kirby almost?
I have no idea. Stop. Check your, before you square anything or move anything or whatever, what can x not be? 3/4. If x is 3/4, all bets are off. Well, this is a rational equation, which I think you did for homework today. This is a rational equation combined with a radical equation. Rational. Fraction, variable in the denominator, watch out. And then it's got the radical because it has a root. I have ideas. What about you? Any ideas for me? Corey, what were you going to say? Yes, yes, yes. The common denominator, this is 1. The common denominator is root 4x minus 3. So I'm going to multiply both sides by root 4x minus 3. Can you, okay, lots of side notes, sorry. What's the square root of 5 times the square root of 7?
35.
Square root of 35. What's the square root of x times the square root of y? Square root of xy. So what's the square root of x times the square root of 4x minus 3?
4x squared minus 3x under squared.
Okay, so that's what's going to happen here. 2 times the square root of x times 4x minus 3. Do you want me to distribute now? Or do you want me to distribute later? Now or later? Make a choice, now or later?
Now.
All right. 4x times x is 4x squared. Negative 3 times x is negative 3x. Minus the whole quantity. Root 4x minus 3 times root 4x minus 3 is 4x minus 3. No, where are you getting 16 from? Multiply a root by a root. Don't forget the parentheses with the subtraction. And what's that going to equal to? Okay, continue. Don't square both sides yet.
Remove the 4.
Isolate the radical. You can square both sides before you divide. The numbers are smaller. I would divide by 2, and then I would square from here. This is another one where the squares become 0. What happens on the left?
4x squared minus 3x.
Thank you. What happens on the right? 4x squared minus 4x plus 1. The 4x squared becomes 0. It's so nice. What do you get for x? X is 1? Well, that's nice. 4x squared, subtract, you get 0. Subtract, you get positive x equals 1.
X equals
Yeah. 2 minus 1 is 1. It equals 1. Yeah? Yeah? Okay, word problems, you're going to need a book, so take a picture of somebody else's. You're going to need a book. So take a picture. We are going to be on page 398. 398, number 17. Take a picture of somebody's book. When I feel like it. The grades have been in Aries for 2 days. Page 398, number 17. 398, number 17. It's all on page 398, doesn't continue.
Ruby problem.
We're doing the rubies. We're going to be doing word problems for the next few days. Well, Friday, Monday. No school next week, for those of you who have forgotten.
Go.
First week. You're going to sleep with me?
Yeah, that's all I'm gonna do.
That's all you're going to do?
And I think we might have CCS next week.
Oh, cool.
Oh my god.
But you don't have to wake up at 9, do you? Like the
We're all
games
gonna
are
have practice at night.
Yeah, we practice at night. That's what you have to wake up early.
8:30.
It's awful.
You know what? If that's how you feel, then you should play a sport. All right, here we go. Page 398, 17. You need a calculator. Sorry, you need a calculator as well. The word problems require calculators. That's simple. You can do them without it. If you have your graphing calculator, use it. Personally, I think it's easier.
Is there an actual law of scientific copy? Is there a patent for it though?
Second log?
Wait, on scientific?
Yeah, usually it's second log. I mean, I don't have it memorized. I think that's what it is. I could be wrong. All right, here we go. Rubies. Page 398, number 17. Oh, this is 7-Eleven. Word problem. It's not a very fancy title, but. All right, here we go. Based on a comparison of prices. Oh, keep in mind that this book is from the 1990s. So, then, what do you mean why? Because this is one of the best math textbooks around.
It says the C.
Pardon me?
It says the C. It says the C word.
You're right. It does say the C word.
Guess we can't do it now.
However, no, that's against the law. It violates copyright laws.
Reworded.
It still violates copyright laws.
Let's change that one word. Change that one word.
That violates copyright laws.
Just write in the book.
Remix.
That's what we can do. I can make all of you take a permanent marker and mark it out. That's actually not a bad idea, but no. Based on a comparison of prices, you find that the price of a ruby varies directly with the fourth power of its weight. Word for word. So like on the final exam, you were told it varied, the first problem, I don't remember what it was about, but you were told it varied linearly, and you guys are all doing exponentials. And you're like, oh my God, the test was so hard. Not if you read it. So what's it mean to vary directly? Yeah, Michelle.
Y equals kx.
There you go. That's a direct variation. But there could be some variations on the direct variation. Michelle, any thoughts? It's okay.
Like y equals kx over z. I don't know.
Okay, so you can have y equals kx and then there's another, but you gotta be careful. If there's a variable in the denominator, it's now rational. It's not direct variation. As soon as you throw a variable in the denominator, asymptotes come into play. As soon as there's a variable in the denominator. What if it's 2? Is that okay? Yeah. You can't change 2, it's constant. You can change x. That's why it's called a variable. All right, where we are. It varies directly with the fourth power of its weight. Give me some variables like define, what's x, what's y, what's p, what's q, what's m, what's n. Yeah, Corey.
Why is it seven?
Y is the price. Price depends on weight. Agreed? A ruby is a piece of jewelry. You know that?
It's red, right?
Say it again.
It's red.
Not all rubies are right.
Really?
Really?
Are you more expensive at all revenue?
Yeah.
I don't think so. I don't know.
Shaped like an egg.
All diamonds are not shaped like an egg.
I said that.
Joking.
He said they're not shaped like an egg. Okay, let's go. Let's
Mine's
focus.
got a diamond.
Okay, shh. What's x? Weight. Okay, so I'm going to change this and you're not going to like it. I'm not using y. I'm using p for price. And I'm using w for weight. Do you have to? No, but you should. Like, you need to get used to using different variables besides x and y. We're very discriminatory, again, with x and y. We need to give the other variables a chance. Okay, so, wait. It varies directly with the fourth power of its weight.
So like w to the fourth equals
So the price is equal to some constant times its weight to the fourth. Here we go. We're going to plug and chug. Suppose that a particular ruby is worth $200. The ruby is worth, actually, I shouldn't say price, we should say worth, don't you think?
Like 2 W's.
Well, I'll say price. How about value? It's value.
We don't give V enough credit anyway.
We don't give B enough credit
Why?
because people can't write properly.
It's so easy compared to B and
Why?
W.
You know what? You use whatever letters you want. It is my job as a teacher to expose you to more variables.
Wait, why did we change this?
Because it says that,
2 cents.
oh, it does say price. Oh, well.
Change it back to B.
You're right. It does say weight. I don't know why I found price. Oh, because it says in the next part that it's price. Do I need to go back or can we just leave it?
No, go back.
Go back.
Don't even care.
Has to be. Gotta
This
be.
is the beauty of the whiteboard. I can just shoot.
I think.
You have an eraser because we all know you do pencil and you do math and pencil. I almost said you do math and eraser. Okay, so the ruby is worth $200. Part A, how much would you expect to pay for a ruby weighing 10 times as much as the $200 one? Let's read that again.
10 times.
How much would you expect to pay for a ruby weighing 10 times as much as the $200 one? Okay, how much does the $200 one weigh? Trick question. How much does the $200 one weigh? We don't know. We don't know. It just says suppose a particular ruby is worth $200. We have no idea how much it weighs, but you want to pay for a ruber weighing 10 times as much.
Can't you figure out if it's for the 4?
Yeah, but we don't have to.
10 times as much as the weight of the original. So what's the weight of the what's the weight of the original? I don't know, but it's 10 times as much.
10 W.
Right? It weighs 10 times as much. So I want to know what its worth is. So what do I need to do? And the original price was how much? 200. So what do we got? I think I have the setup incorrect on the board, but I know it in my brain, so I'll fix it. Calculator. What's 200 to the 4th? I have it wrong on the board. I know I do.
Oh,
What's that? It is a big number.
200 to the 4th.
I don't know if there is.
16.
I can't even get that many zeros.
1.60.
16 and 7 0.
16 and 7 zeros.
1.6 times
It's 1.6.
8.
7, 8.
1.6.
There's something wrong. It's not supposed to be $16 trillion. If you have a diamond or ruby, whatever, worth $16 trillion, you're in good shape. Good luck finding someone to buy it from you. There's a mistake. What did I do wrong?
You're supposed to erase 200.
It's not 200 to the 4th.
It's not 200 to the 4th. What's the problem?
It's 4 to the
4 to the 200? Any idea how much that is?
No, but it's
Where's
a
your
lot.
calculator?
Error
Oh my
overflow.
god.
Error. Too many numbers.
That's an overflow.
Tyler? Is it a root?
Error over.
it's still price.
It's still price. Okay, let's go back because there's a mistake here. So I'm going to erase. There's a mistake. Stop. First of all, I make mistakes. Second of all, that's how you learn best, is by making mistakes and you erase them then. It is okay that I make a mistake. So we know that there's a ruby and its weight is unknown. But we do know that it's worth $200 or it was worth whatever, $200. Do we agree? Okay. Yes? Okay, that's the beginning. I have that correct, I believe? Yes. Okay, so now I want to know the worth of the ruby, which, how much more does it weigh? It weighs 10 times as much. Oh, I forgot the equation. Price is equal to some weight. That's where my mistake was. That's where my mistake was. That's with the K. It's a direct variation, so that's where my mistake was.
It's directed
Yes, no. So what am I gonna do?
So 200 to the
200?
fourth root of 200 to find the weight.
The fourth root of 200 is gonna tell me the weight?
Then you can put 200 as P, and then like you try to find W for the weight, and
Kabine, what are you saying? Speak up, please.
then so P is equal to 200 because that's how much.
That's how much it's worth, yeah.
So then if P is equal to 200, then 200 is equal to W to the fourth because it's, and then you could find the fourth root of 200 to find W.
Okay, so, yes. So right now we're at the 200, that's the price, and that equaled some weight to the fourth power. We didn't know what that weight was, right? I wrote weight. I'm having a hard time talking. I wrote weight was a question mark, so I kept the question mark here. So first let's solve for W and leave the number in your calculator. How do I solve for W? Fourth root, yeah. So in your calculator, do you know how to fourth root on your calculator? Yeah, there's a couple ways. You can do this the 1/4 power, but let me show you another way. So W is 200 to the 1/4. Okay, on your calculator, if you go to math, you know how we do math graph? On your calculator, if you go down to math and you go down to number 5, which says X root, and then you can type in the 4 and type in the 200. Yeah.
I did it before and I got the answer. It's like 3.7.
Okay, so that's what W is. Leave the number in your calculator. Leave the number in your calculator. I'm just going to write it on the board as a rounding. So, is it how much weight? Millimeters? What's the weight? It doesn't tell you. What's like? Is this in? We're not in pounds, obviously. It doesn't say.
Shame on them.
It does. Shame on you. Okay, so what's this mean? A ruby that weighs 3.76 units. Let's just say ounces for the make it easier. A ruby that weighs 3.76 ounces is worth $200. A ruby that weighs 3.76 ounces, put the numbers in your calculator, is worth 200. So we have a point that we could graph if you wanted to. Yes? Okay, so we haven't answered the question yet. So the question says, how much would you expect to pay for a ruby that weighs 10 times as much? Okay, so my price, my ruby that weighs 10 times as much. So raise that number times 10 to the 4th. It is not 16 zeros, $2 million.
Yes.
I would not spend that
That's
much
one
on a ruby.
expensive ruby.
Jewelry is one of the few things that appreciates in jewelry, artwork, and real estate. The only physical things that actually appreciate in value, meaning over time their value goes up. And not all jewelry and not all art, but
Like if it's like more antique or something.
What about artifacts?
Very
Or like
collectibles.
museum pieces?
It's art.
No.
Over time. they
yeah,
get destroyed.
artifacts are art. I mean, depending, right? But they're what's the word? Worth money. I can't think of the word. Valuable.
Cars become valuable if they're old enough.
Cars become valuable if they are very, very old and are well taken care of. You are not going to see a Tesla that's going to become an antique.
Steal this.
I mean, like making examples.
Yeah, no.
That's a
Nate, do you listen to what you say? In 200 years, there's going to be a Tesla that's an antique. There's so many of them.
I know, but what if it's the last one left? I mean, like there's like a.
It's gonna go and destroy every single Tesla and just.
Okay, enough. Let's move on from the Teslas. Let's move on from the Teslas. I disagree. Let's move forward. How much would you expect to pay for a ruby weighing 1/10 as much as the $200 one? So if I want it to be,
I don't think I do.
what is it, a fourth, a tenth?
2 cents.
A tenth. So this time it's going to be P
I would
equals
buy that one.
3.76 times 0.1 to the fourth. $0.02?
Yes.
Nobody wants a
Buy that
2
one.
cent ruby.
I would.
It's a little baby.
0.37.
What would you?
So this one is rare. The $2 million ruby isn't around at your average jewelry store. Neither is a 2 cent ruby. But in the big picture, this is rare and this is not. Yeah?
I don't think you could get 2 cent ruby on a necklace or something.
Okay, let's take a break and we'll do more word problems when we get back.
Ruby dust.
This guy, like, what about the Etruscan war vessel? That's pretty valuable, really.
I don't have any idea what you're talking about.
You don't know about the
The what?
I just dropped $100.
Etruscan war vessel.